Let's practice simplifying or SimpLEEfying each fraction using the GCF together. For each of these practice problems, I'm going to show you two different methods using the prime factorization method and the ladder or cake method, but feel free to choose whichever method works better for you. For number one, we have the fraction of 15/20. Now, using the prime factorization method, all we have to do is break up each of the numerator and denominator into its prime factorization and then cross out common prime factors. So 15 gets broken into what? I think that's going to be 3 times 5, and 20 on bottom is going to break into 2 times 2 times 5. Now, if you need to make factor trees, feel free to do so, but these numbers aren't too big, right? Now, if you take a look at these now, in the numerator and denominator, you can notice that they both have a 5 in common, and I think that's going to be it. So it turns out that if you go ahead and take 15 and you divide it by 5, and you divide by the 5 that we crossed out on the bottom as well, then this fraction, when it's simplified, is just going to be 3 over, and then on bottom, we're going to multiply this 2 by 2 together, and that's going to equal 4, right? So the GCF here that we used, the GCF, was equal to 5. Now, what was the most simplified version? The most simplified version for 15/20 is 3/4. Okay? Now, 3 and 4 are relatively prime, or their GCF is 1, which is why we know we can't simplify anymore. Now, what's another way of doing this? Well, we can also use the ladder method, which is a little bit quicker. You can take 15 and you can take 20 and just write the fraction just like this, and think of what do they have in common. And if you think of 5, that's great. 5 goes into 15 3 times, it goes into 20 4 times, so then you get this fraction of 3/4, which does match this 3/4 that we got earlier, and you can see the GCF is still 5 on the side there. For number 2, we have the fraction 3/12. So let's see what this is going to look like. We can take the fraction of 3/12 and think about what prime numbers can we break each the numerator and denominator into. Now, the 3 on top is already prime, so leave it alone. 12 breaks into 2 times 6, and then 6 breaks into 2 times 3. All right. Now, if you look at the top and the bottom, notice how they both have a 3, and that's it. So the GCF here is going to be 3. We can divide both the top and bottom by 3. And if you do that on top, notice how there's no more numbers. You can always write a 1 there, okay, because 3 times 1 is still 3. And if you do that, we're going to be left with a 1 on top. And then if you multiply this 2 and 2 together on bottom, we're going to get 4. So in the denominator, we'll have 4. And so the most simplified fraction here is 1/4. 1 and 4 are relatively prime. What was the GCF we used? The GCF was 3. That was the greatest common factor between the numerator and denominator. Now, for the ladder method, just take this 3 and put the slanted fraction bar just like that, and put the 12. And what do they have in common? Well, they both have a 3. So 3 divided by 3, that's going to be 1. And 12 divided by 3, that's going to be 4. So we have this fraction of 1/4. And the 3 on the side tells you the GCF, or what we divided both of them by. For number 3, we have this fraction of 9/15. So I'm going to take this 9 on top and put the 15 on bottom. And let's think how we can break up 9. I think 9 is going to break into 3 times 3. And then 15 is going to break into 3 times 5. All right, so what do they have in common? Looks like they both have a 3 on top and bottom, which is their GCF. So divide both by 3. There's nothing left they have in common. So all we have is a 3 on top and a 5 on bottom. And so that is as low as we can go, okay? The GCF here is going to be 3. That's what we divided top and bottom both by. Now, using our other method here, we have 9/15. It's going to write the original fraction just like this. And what goes into both? We can say it's a 3. 3 goes into 9 3 times, and 3 goes into 15 5 times. So this 3/5 at the bottom does match, and the 3 on the side was our GCF. For number 4, we have 14/21. So let's go write the original fraction. And let's think, what can we break 14 into? 14 breaks into 2 times 7, and 21 breaks into 3 times 7. All right, so top and bottom looks like they both have 7s, so that's going to be the GCF. So divide both top and bottom by 7 since they're common factors. All we have left on top is a 2, and on bottom we have a 3, and that is as far as we can go. The GCF we use here is equal to 7. Using our other method, we can take the 14 and 21, put them right next to each other like this. And what do they have in common? Well, I think it's a 7, we already decided. 14 divided by 7 is 2, and then 21 divided by 7 is 3. So this 2/3 does check out. For number 5, we have this fraction of 5/12. So let's go ahead and rewrite this. So we have 5/12. And let's see if we can break this up. So 5 is already a prime number, so that's going to stay the same. 12 is going to be 2 and 6. We can write the 2, and then 6 is going to be 2 and 3. All right. Now, if you notice here, they have nothing in common. So that means that 5 and 12 were relatively prime, or their GCF was 1. So this is still just going to be 5/12. So this one's kind of here just to help you understand that sometimes you can't simplify a fraction, right? And it all comes down to whether they have any common prime factors anymore. So what was their GCF? It's not that they didn't have a GCF. Their GCF is 1, which means that they were originally relatively prime, and you wouldn't be able to simplify the fraction, okay? So the definition of can you simplify a fraction? Well, it depends if their GCF is 1. If their GCF is 1, then you can't simplify a fraction anymore. So this is what the ladder method would look like, but it's really short. For number 6, we have the fraction 8/20. And let's see what happens if we break this down. If you've done a lot of prime factorizations, you might know 8 already breaks into 2, 2, and 2. Right? And then 20 breaks into 2 times 2, which is 4, and then 4 times 5 is equal to 20. And what do they have in common? Well, they both have a 2, and they both have another 2. So 2 times 2 is 4, which means that 4 would be their GCF if you multiply the common primes together. And then we're left with a 2 and a 5 afterwards, right? Because 8 divided by 4 is 2, and 20 divided by 4 is 5, and that's also the leftover number. So this is going to be 2 and 5. And so we can say here that the GCF, or the greatest common factor, was equal to 4. Now if we use the ladder method, we can take 8 and 20. This way is definitely faster. And you could do 2 and then 2 again, but I'm just going to go with 4 right from the beginning. 4 goes into 8 2 times, and 4 goes into 20 5 times. So this 2/5 does match this 2/5. For number 7, we have 18/27. So let's go ahead and write that. And while I'm writing, let's kind of think about what we can break 18 into. And so we have 2 times 9, and then 9 breaks into 3 times 3. So that's 18's prime factorization. For 27, we have 3 times 9, and then 9 will break into 3 times 3. So we have 3 3s for 27. Both top and bottom have a 3 in common, and then another 3 in common. So 3 times 3 is 9. So that means we can divide both of these numbers by 9. Okay. 18 divided by 9, we're left with a 2, and then 27 divided by 9 is going to be 3, and so that is going to be our most simplified fraction. GCF here is equal to 9. Using the ladder method, we have 18 and 27, and let's see, we can divide both of these two numbers by 9. We've already found that out, so 18 divided by 9 is going to be 2, and 27 divided by 9 is going to be 3, so this 2/3 matches this 2/3 here. For this number 8, we have 15/30. So if you know 15/30 is already equal to 1/2, then that is wonderful. But I think it's also kind of cool to see like why that happens and how everything kind of works out with everything we've been doing. So 15 breaks into 3 times 5, right? And then 30 is going to be 2 times 15, and then 15 breaks into 3 times 5. Now what do they have in common? Well, it looks like they both have a 3 in common, and they both have a 5 in common, right? So 3 times 5 is 15, which means you can divide these both by 15. If you look at top at the prime factorization, there's no more numbers, so you can always write it times 1, because you can always multiply something by 1 and it stays the same. And on bottom, we're left with 2, right? So 15 divided by 15 is 1, and then 30 divided by 15 is 2. So 1/2 makes sense, right? And our GCF we used was 15. Using our other method, we take this 15 and 30, and we go ahead and say what goes into both of them. Well, at this point we know it's 15, and then 15 divided by 15 is 1, and 30 divided by 15 is 2, so this 1/2 checks out. Here's number 9. For number 9, we have this fraction of 18/24. So we take a look at the prime factorization here. 18, we've done it a few times here, but 18 is going to be 2 times 9. 9 breaks into 3 times 3. 24 we can say is 2 times 12, and 12 will break into 2 times 6, and then a 6 will break into 2 times 3. Alrighty, so these are the prime factorizations. What do they have in common? They both have a 2, and they both have a 3. I think that's it. So 2 times 3 is 6, so we know the GCF here is going to be 6. We can divide them both by 6, and we're going to be left with a 3 on top in the prime factorization and a 4 on bottom, because 2 times 2 is 4. So 3/4 would be equivalent to 18/24, and we knew the GCF here is equal to 6. All right. In terms of using the other method, obviously we know the GCF is 6, so we can just set it up like this, but you can always do this method as well and divide both by 6 right away. 18 divided by 6 would be 3, and then 24 divided by 6 is 4. So this 3/4 matches, and the GCF is clearly written on the side. For number 10, we have 27 over 36. So let's go ahead and write that. And let's see what's going to go on here. So 27, I think we've done this one already, but that is 3 times 3 times 3. Again, feel free to make a tree if you need to. And then 36 is 2 times 2, which is 4. 4 times 9 is 36, but 9 breaks into 3 times 3. So they do have a 3 in common and do have another 3 in common. I think that's it. 3 times 3 is 9, which means you can divide both of these by 9. And 27 divided by 9 is the leftover 3. And then 36 divided by 9 is the leftover 2 and 2, which makes 4. So 3/4 would be our final simplified fraction here. Our GCF was 9. And then for our other method, we just go ahead and write these side by side. So we write 27 and 36 next to each other. And you could divide these both by 3, then 3 again, but we already know it's 9 from using the other method. So typically you won't have the other method there because you won't have to do both every time, but we still get 3/4. For number 11, we have 45 over 60. So these numbers are getting a little bigger. So 45 over 60. And so let's see what 45 breaks into. I think 9 times 5, and 9 breaks into 3 times 3. So 3 times 3 is 9, 9 times 5 is going to be 45. For 60, what do we have? 2 times 30, and 30 can divide by 2, that's 15, and then we have 3, and then we have a 5. So what do they have in common? They both have a 3, and they both have a 5. So 3 times 5, that means the GCF must be 15 here. You can divide them both by 15. And if we do that, on top we're left with a 3, and on bottom we're left with a 4. So 45 out of 60, or 45 minutes out of 60 minutes would be 3/4 of an hour. So the GCF we used here was 15 when we divided them both by 15. If we're going to go ahead and write it this way, we now know 15 is the GCF. So if you didn't, you could have used 5 and 3, but now we know this is going to be 3 and 4 for the most simplified version. So 3 and 4 are relatively prime. All right, number 12, this is our first improper fraction, but keep in mind that just because a fraction is improper doesn't mean we can't simplify it. It just means that we're going to try to still get the numerator and denominator to be relatively prime. Again, it doesn't matter if it's improper or not. So let's see here, 80 breaks into 2 times 40, 40 breaks into 2 times 20, 20 breaks into 2 times 10, 10 breaks into 2 times 5. So there's the prime factorization for 80. Feel free to make a tree if you need to. For 48, we have 2 times 24. 24 breaks into 2 times 12. 12 breaks into 2 times 6. And 6 breaks into 2 times 3. So on the top, we have a 2 in common. We have another 2 in common, a third 2 in common, and a fourth 2 in common. Now 2 times 2, that's going to be 4. 4 times 2 is 8. 8 times 2 is 16, which means that 16 must have been the GCF here. So if you combine all those common primes, then it's 80 divided by 5, we know, or 80 divided by 16 rather, is going to be 5, and 48 divided by 16 is going to be 3. So again, we're not looking to convert forms, like convert this to a mixed number. That doesn't mean it's simplified. Simplified means that the numerator and denominator are relatively prime. So the GCF here was 16. Now if you're using the ladder or the cake method, you can totally set it up like this. A lot of people might start with 8 and then they would probably do 2 again after, but we already know it's 16 because we used the other method, and 80 divided by 16 is 5 and 48 divided by 16 is 3. So this 5 over 3 hopefully checks out and makes sense to you. For number 13, we have the fraction here, 56 over 70. So let's take 56 and let's think about what factors we have that we can break it down by. 70 is maybe a little bit easier because it ends in 0. But for 56, I'm thinking 8 times 7, and 8 is just really familiar to me because I've done it so many times. 8 is 222, and then 7, right? Now for 70, we can definitely do 2 times 5 for 10, and we still have a 7 for 70, so let's do 2 and then 5, that's 10, and then 10 times 7 is 70, okay? Now what do they have in common? Looks like they both have a 7, and they both have a 2. So what's 2 times 7? 2 times 7 is 14, so 14 must be the greatest common factor between 56 and 70. And on top, 2 times 2 is going to be 4, and on bottom we're left with a 5. and so that must be the most simplified fraction here. So we got that 4/5 for the most simplified fraction, and the GCF we used was 14 to get there, okay? Then of course, just showing this other method to make sure everything checks out, you can see that these two numbers here, probably a lot of people would start with maybe 7 or so, but we're gonna start with 14. 56 divided by 14, that's going to be 4, and then 70 divided by 14, that's going to be 5. So 4/5 would be the most simplified version because 4 and 5 are relatively prime, or the GCF is 1. Here's 14. For 14, we have 18/35, so 18 over 35. And so 18, what does that break into? 18 breaks into 2 times 9, and 9 breaks into 3 times 3. 35 will break into 5 times 7. At this point, we've confirmed they have nothing in common with each other, right? There's no common primes. So if that's the case, then our most simplified fraction is still going to be 18 over 35, right? So if we take a look at this, we can say, well, we can divide both top and bottom by 1, I guess, right? But they had nothing in common, so 18 over 35 is a fraction that just can't be simplified, right? They have nothing in common, or they are relatively prime at 18 and 35. So the GCF here is equal to 1, which is why we couldn't simplify. And then if we go ahead and take a look at this, if you didn't write the prime factorizations, you might be thinking for a little bit and confused, or if you're not sure, you're like, I can't find anything in common. It's because they don't have anything in common. And the breakdown using the prime factorization method kind of shows that they had no building blocks that were the same, so you wouldn't be able to. Moving on to number 15. For 15, we have this 96 on top and then 72 on bottom. And these numbers are a little bigger, so you may need to pause and make a tree if you need to. Feel free to. 96 is 2 times 48. 48 would be 2 times 24. 24 would be 2 times 12. 12 would be 2 times 6, and then 6 would be 2 times 3. So this would right here would be the prime factorization for 96. And then for 72, that's 2 times 36, which is then going to be, 36 is going to be 2 times 18. 18 is going to be 2 times 9, and 9 is going to be 3 times 3. So that's the prime factorization for 72. They both have a 2 in common, they both have another 2 in common, they have a third 2 in common, and then they have a 3 in common here. Okay, so if we go ahead and see, okay, 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is going to be 24. So the GCF here is going to be 24. It's the biggest number they have in common. So on top, this 96 divided by 24, that's going to be 4, and that makes sense because you have these two 2's on top left, and on bottom, 72 divided by 24 is going to be 3. That's the 3 that's left in the prime factorization, so we have 4/3 at the very end. And what was the GCF we used? Well, all those crossed out numbers multiplied, we get 24. That's what we divided top and bottom both by. And putting these two numbers side by side using the ladder method, we can see here that we could probably start with smaller numbers if you weren't sure, but now that we know it's 24, let's again just put it there. Just put one layer here, and then that's going to be 96 divided by 24 is 4. 4 times 24 is 96, and then 72 divided by 24 is 3, because 3 times 24 is 72. So these 4 and 3's, or the 4 and 3, are relatively prime. Okay. Final one, we have 95 and 57. All right, so put the 95 on top and put 57 on bottom. Let's see, 95 is divisible by 5. Turns out that it's going to be 5 times 19. Okay, and then for 57, you have to use your divisibility rules a little bit here maybe, but since 5 plus 7, I'll go ahead and write this out, 5 plus 7, that's equal to 12, and that is a multiple of 3, right? So if you can divide this by 3 and you get 4, I know this work doesn't really make sense the way I'm writing it, but since that checks out, then you know you can divide 57 by 3, and it turns out that 57 divided by 3 is going to be 19, so 3 times 19 is 57. Now on top and bottom, 19 is common, so 19 is actually a GCF. So on top here, 95 divided by 19 is equal to 5, which is what we were left with. And on bottom, 57 divided by 19 is going to be 3. So we have a final fraction of 5/3. 5 and 3 are relatively prime. And our GCF that we use to kind of get this smaller version of the same fraction is going to be 19. That was their GCF. And we can see this written another way here as well. Again, for this way, it is quicker and less work maybe to write, but you do need to see if you can come up with these factors on your own, or these common factors. So
19 goes into both. 19 times 5 is 95, and 19 times 3 is 57, so that makes sense that 5/3 is our final answer.
So there you have 16 different practice problems on simplifying or simplifying fractions using their GCF. I went over it using the prime factorization method so you could see all the building blocks to see where the GCF comes from. But again, if you can find that using the latter method and not do that, then that is great as well. But hopefully both methods help to understand it and see the connection a little bit more clearly. So as always, keep up the great work, and I'll see you in the next one.